Our next problem actually happens to be in slope-intercept form. Yay, our first one so far. So I actually have a whole lot less work to do here. My m for my blue equation, because it's already in the slope-intercept form, is just merely the number in front of the x, which is 2, or I can write it 2 over 1. My b is 1. So if I go to my y-intercept and put a point at 1, because that's my y-intercept, my b, and then I'm going to rise 2, run 1, rise 2, run 1, rise 1, rise 2, run 1, or you go down 2, left 1, down 2, left 1. Again, I'm not going to draw my line until later, just so I can see my points really clearly. My second equation is also in slope-intercept form, so my m is negative 2, or I can write that negative 2 over 1. My b is negative 3. So put a point at negative 3, and then I go down 2, right 1, down 2, right 1, down 2, right 1. As you can see, if you continue to go down 1, right 1, you're never going to reach the blue line. You also have to do its opposite, which is up 2, left 1. And there we go, we finally found the spot. So up 2, left 1. But the point at which they both intersect looks like negative 1, negative 1. That one's over just a little tiny bit right there. Negative 1, negative 1. So my solution to this equation is negative 1, negative 1. Okay, now that I have the solution, I can go back and draw my actual lines. And if you had, like on MATLAB software, and you could probably draw the line first. It's just with my, handwriting here, if I draw the line first, it's kind of hard to see which one is which, so I like to do it this way. For our next problem, x minus y equals 3 is not in slope-intercept form, so I'm going to write it over here. I want y all by itself, so I have to move the positive x to the other side. Notice the negative stays with the y because the negative always goes with whoever's behind him. Because I take the x and move it to the other side, that changes his sign because he's changing teams, right? And then I'm going to divide everything by the coefficient of y, which is negative 1. This leaves me with y equals negative 1 divided by negative 1 in front of the x is positive 1x. Positive 3 divided by negative 1 is negative 3. So my slope is 1, or I can write that 1 over 1. My b is negative 3. So I put a pencil on my y-axis at negative 3. Rise 1, run 1, rise 1, run 1. All the way off my picture. I could also go down 1, left 1, all the way off my picture. I'm going to leave those as dots for now. Then I'm going to come back and grab my second equation, which is 2x minus 2y equals 6. I want the y to be by itself, so I'm going to take the 2x and move it to the other side, which leaves me with negative 2y. The positive 2x moves to the other side and changes his sign to be negative 2x plus 6. The positive 6 and the negative 2y didn't change signs because they didn't move. The only thing that moved is the 2x, that's the thing that changes signs. So now I'm going to divide everything by the coefficient, which happens to be negative 2. And this leaves me with y equals, the negative 2 divided by negative 2 is positive 1. Positive 6 divided by negative 2 is negative 3. So my m in red is 1, or 1 over 1. My b is negative 3, so I'm going to put a pencil on my negative 3. Rise 1, run 1, rise 1, run 1, rise 1. What do you notice here? The two equations are exactly the same. So my blue line, if I drew my blue line in, turns out to be the same as the red line. And you could also figure this out by realizing that the slope on both the red and the blue are the same. And the y-intercept of the red and the blue are the same. So therefore they're going to be the same line. So what is my solution? When the lines coincide, my solution is that long equation. In set notation, the set of all x, y, such that, and then one of the two equations. Pick whichever one you like better, write it in, and that is your solution. So that's an example of two lines coinciding. Our last example for graphing, I'm going to do the first equation in blue, x plus y equals 4. I need to move the x over, so that's y equals negative x plus 4. Because I took the positive x and it changed signs, it moves to the other side and change signs. So my m is whatever's in front of the x, which is negative 1, or I'm going to write that negative 1 over 1 because I like it as a fraction, and b is 4. The red equation, I have 2x plus 2y equals negative 6. So I pick the 2x up and move it to the other side. The 2x sign turns into negative 2x. And then I'm going to divide everything by 2 to get the y all by itself. So I have y equals negative 2 divided by 2 is negative 1x. Negative 6 divided by 2 is negative 3. So my m is negative 1, or negative 1 over 1, and my b is negative 3. So for my blue equation, I start at 4, and down 1, left 1, down 1, left 1, down 1, left 1, all the way off my picture. Or I could go up 1, left 1. Okay. So for the red, I'm starting at negative 3, going down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1. These are not looking like they're getting any closer at all. These two lines appear to be parallel. They started at different points, but they went in the same direction, which means they're never going to cross. So the paths will never, ever, ever cross. So the solution here is no solution. Okay. One way we could have realized that is if you looked at the slopes are both negative 1. So they're both going in the same direction. But also, very importantly, the y-intercepts are actually different. So because the y-intercepts are different, they're never going to match. The slopes are the same, but the y-intercepts are different. Therefore, it's going to be a no solution because they're never going to cross. They start at different spots and walk in a different way.